One of the most striking things when you first open Wireshark and look at an existing capture or start capturing your own packets are the colors that are used to denote specific meanings amongst the packets that you'll see. Just on the screen here, you see a lot of green packets and you see a few blue packets. I can scroll down here to the bottom and you'll see a lot of these black packets with red text on them. So simply by modifying the background color and foreground color, or the text color of a packet, that is going to imply specific meaning, and that's a really useful thing when you're doing analysis, is to be able to associate certain characteristics with colors. After all, the brain is really good about picking up on those color differences and kind of automatically helping you associate those packets with a certain way of thinking based upon what it sees with the color. And that's one of the reasons Wireshark takes advantage of these pretty colors and these coloring rules that allow you to do this. Now, I always get amazed when I talk to people who maybe have even used Wireshark a lot, and I ask them if they have any custom color rules, and they'll say, wait a minute, I didn't know you could have those. And that blows my mind, because I think this is one of the most fascinating and useful features of Wireshark, is the ability to kind of take the coloring of packets and manipulate that really to your heart's content and in a lot of different ways. So in this demo, I'm going to show you where to view and edit coloring rules, and talk through a few scenarios in which you might want to apply specific color coding to certain types of packets, and how you can colorize protocols or conversations, or colorize based upon specific filters. So let's start with some very focused specific questions. If I scroll all the way to the top of this packet capture, we see we have both blue and green packets. So those are both blue and green backgrounds with black foreground. So what exactly is the reason behind why these are colored that way? Why are these DNS packets colored blue, and why are these TCP and HTTP packets colored green? Is that a question we can answer? And the answer, of course, is going to be yes. And we'll do that by clicking up here on the View menu, and then going down to this Coloring Rules section. So if I click that, that's going to bring in the list of default coloring rules that are used within Wireshark. So all of the various coloring of packets you see is actually based upon just a small number of rules that are really a catch-all for a lot of the more common things you'll see. Now, in this case, we first ran across blue packets, those blue packets with the blue background and black foreground. And you can look on the screen here and see at the very bottom, we have that same color right here where it says UDP. In this case, we have a name column, we have a filter column, and that's telling us that the coloring rules we're seeing are based upon Wireshark's display filters. And we'll talk about display filters and how to build them, how to create them in a dedicated section later. But suffice to know that to create a coloring rule, all you really have to provide is a name for that rule and a filter. And anything matching that filter will match that coloring rule. So in this case, DNS, those first couple packets are DNS packets. DNS is based on UDP. So we have here UDP is going to be filtered here, which is this very simple UDP filter, and those packets are going to match blue. Now below that, we have a lot of TCP and HTTP packets. Now you'll see that we have a filter at the bottom for TCP right here, and it's kind of this bluish purpley gray color. Depending upon your screen, it may show up a little differently, but it's this kind of duller color. Now, with that said, why are the packets on our screen showing up green and not showing up this other color matching this TCP filter? Well, the reason is that the rules are processed here top to bottom, and they basically match the first one they come to. So if you start at the top here and think about our packet and think about which one is going to match, you actually come to this rule first, this HTTP rule. In this case, all of the packets that are green here are matching this rule first because they fit this filter, which says either they're detected by the HTTP or HTTP2 protocol dissectors, or they're simply matched on TCP port 80. In this case, both of those things are going to be true. So this is going to match the HTTP coloring rule, which means it's going to stop processing. It's not going to go any further. It's never going to get to this TCP processing rule, even though the packets would also match this filter too. So in this case, the order matters, or in all cases, the order matters that you have these coloring rules in. And you really want your more specific rules towards the top of this file and your less specific ones at the bottom. And that's exactly what you see. The protocol, broad level transport protocol rules, TCP and UDP, are here at the very bottom, whereas a lot of your error states you would see, such as bad TCP packets, things with certain particular sets of flags, window updates, OSPF changes, spanning tree notifications, ICMP errors. Those are near the top because those are the things you're going to want to see before you see the other stuff. So you're looking at error states before you're looking at normal color coding. That's what allows us to have these packets that have a black background and a normal or a red foreground. So let's actually play around with these things and create our own rule that's going to color DNS packets a different color. And the order is going to matter here because remember, we're already matching one coloring rule. We're matching this rule down here for UDP. But we want to actually create one that's going to match something a little bit more specific, and we're going to put it higher up. So let's go ahead and do that. To do that, I'm going to click this plus down here. And it's going to create a new coloring rule. It's going to put it all the way up here at the top. I'm going to go ahead and call that DNS. Now in the filter area, I'm going to double click in here, and very simply, I'm just going to put a filter for DNS. Sure enough, pretty straightforward, right? Now we want to use some interesting colors, so we'll click down here for background, and I'll go ahead and make that, let's see, my favorite color is blue, so let's make the background a bright blue. We can't really... The foreground in this case would be black. Let's go ahead and make that white. That's probably going to be a little bit easier to see. And we see that reflected up here. So DNS traffic will appear with this bright blue, Kentucky blue, if you will, background, and white foreground. So I have that all the way at the top. So that should work as is. So if I go ahead and click OK here, we'll see that the DNS packets in this case are indeed colored a nice pretty shade of blue. So that coloring rule is now taking effect instead of the UDP rule that was applied. So I'm going to go ahead and go back into that coloring rules, and let's actually move that. So let's actually move that down. So I'm going to click and drag this all the way under UDP. So I just clicked and held and drug that under, and I'm going to hit OK again. And sure enough, they changed back. So you see how the ordering matters in this case. Whatever rule is matched first is going to be the rule that is applied, as this is basically top-down processing from the top of this list down to the bottom. So how can we get a little bit more specific with our coloring filter? Well, what I'll go ahead and do here is take this DNS filter. We'll go ahead and move it just above UDP. That will make sure we're hitting that before we hit UDP here. Matter of fact, I'll go ahead and move it above TCP as well, since you can have DNS packets that are TCP. So we have that above the transport layer protocols, so it should be hit there when we see those, at least those couple of types of packets. Now, let's create some rules that are a little bit more specific. Let's say we want to create a rule, one for a DNS request and one for a DNS response that will color code those differently. So I'm going to go ahead and apply this, hit OK, and we're going to see we have those coloring rules applied. Now in this case, I've got I've clicked on the first packet and I've expanded the packet details for the DNS application layer header. I've also expanded the flags, and we have this section here that tells us this message is a query, and that's based upon this specific couple of bytes. Now, if I click on packet number 2 here, you'll see it says this message is a response. So this set of bytes here is going to tell us whether a DNS packet is a query or response, and I want to create a coloring rule based upon this. Now, I could go and look up the specific filter and do all that, but that's a little cumbersome, and quite honestly, we can do it a little faster. So I'm actually just going to right click on this value, go to colorize with filter, and then I have an option here at the bottom for a new coloring rule. I can go ahead and pick one of these default 10 coloring rules, but I'm just going to click on new coloring rule here. And you'll see it's going to take us back to this same coloring rules screen and create a new rule at the top based upon the appropriate filter. So in this case, DNS.flags.response equals 0. So I'm going to accept that. I'm going to go ahead and name this DNS query. So this is the query. It's not a response. We'll go ahead and leave that at the top. And let's go ahead and give it some useful colors. Let's say we'll make the queries have a background that is red and a foreground that is white. So red and white, pretty easy to deal with. So I'm going to go ahead and OK that. we'll see here our query in this case has turned red. We'll focus in on this one. It's a little easier to focus in on one at a time. And we see that our queries turn red, and now our response in this case is blue. Now let's go ahead and look at back at those coloring rules just one more second. So here we see the query is going to be red, and it's not going to match again until it gets to this default DNS coloring rule that's blue. Let's go ahead and make one more of these specifically for responses. So I'm going to focus in on the same set of fields, and in this case, again, colorize with filter, new coloring rule, and it's going to say dns.flags.response equals 1. So it's saying this is a response. So I'll go ahead and call this DNS response. We'll give this another color. Let's say we'll call this one, we'll give this one a really bright green, and we'll leave the foreground black because black's easier to see on green in this case. So I'll hit OK here. And there you go. So we have our requests are in red and our response are in green. And these are very, very easy to notice here. So as I scroll down, we can see more of these. In this case, you'll see it comes in handy because we have two requests happening at once, followed by the replies. So they're not always going to be request, reply, request, reply. Sometimes the requests and the replies might be separated a little bit, and the coloring rules allow us to see this separation and see that in this case, these first two DNS packets are probably not associated, or at least not associated in the concept of one is a response to a specific stimulus. In this case, this one is probably going to be associated here, and this one's going to be associated here. And of course, we could look at the DNS transaction IDs to verify that. But the coloring rules, you kind of see the point of what they're hoping to do here. And I can scroll down here, and as we continue to do that, we can very quickly spot our DNS requests and replies, which is kind of nice. Not every situation you're going to want to create a filter just for DNS queries, for instance. You may want to scroll through and look for those in the context of other traffic. And doing this way, applying these coloring filters, certainly helps and gives us a better mechanism for doing that, and just another tool to really help in the analysis here. So to go a little further, I might take these and I might drag them a little bit lower. So I might put them, I don't know, maybe at least right here. Maybe not the first thing we want. Maybe we want to see the TCP errors and things above that. Again, you want to keep your error states at the top and your more broad stuff here at the bottom as kind of a catch-all. But nonetheless, these are now in a little bit better place. And we have some really great DNS coloring rules that will catch both responses, queries, and just general DNS traffic beyond that. Now, there are a couple of other things worth mentioning on this screen that we haven't talked about yet. Particularly, you have the ability to export and import coloring rules, which is pretty neat. So let's say we had a whole bunch of custom protocol coloring rules that we wanted to share with other people in our organization, which is certainly something I'd recommend doing. You can actually go down here and click this export button, and it's going to allow you to export a file containing all these coloring rules. Now, what you can do is take that file, email it, or put it on a USB flash drive and give it to your colleague. They can go to this same screen on their Wireshark, click import, and import the file containing all of those coloring rules, and it will add those to their list. In most organizations, if you're working with other analysts or working with other IT admins who might get benefit from this, I certainly recommend exporting your coloring rules when you get a lot of them built out and sharing those. Maybe you have a default location you can dump those all to where everyone can continually export, and you combine and maintain one particular file with coloring rules. I think for the most part, everyone is going to want to have their own unique set that they rely on. But sometimes when you're doing peer analysis and oftentimes you're handing packet captures from one person to another, especially in security when you're maybe in a security operations center environment, you want to be trying to use the same color coding rules when you can, especially if you're going to be putting some of these things up on the big screen or making reports that have screenshots. You want to try at least for some level of consistency, and exporting and importing coloring rules like this is a great way to achieve that level of consistency, as well as, like I said, being able to share and help educate and teach others or learn from others within your organization by sharing coloring rules. I want to go through just one more coloring feature that I find really helpful, and probably one I use more than any other coloring feature. So I'm going to go ahead and OK out of this. And you'll see the conversation or the packet capture I'm looking at right now has a lot of packets in it. So it's 569 packets, and we've got a couple of different conversations going on here. So I can go to statistics, conversations, and go to look at the IP conversations, and then there's a lot of those. When you're scrolling through a packet capture of even a very isolated event, there can be a lot of different conversations, and it can be kind of tricky to keep those straight, especially if you're trying to systematically process through a list of packets and go through and see what you can see. Ideally, in a dream world, all of our conversations we're going to look at, or all of our captures, are going to be a single conversation, but in the real world, that's not the case. This capture file we're looking at now is actually just a single visit to ESPN.com, which is going to rely on conversations with a lot of different content delivery networks that contain images and videos that are part of the ESPN website. And we see a lot of those listed here, at least at the time of this capture. So there are a lot of them, and I can filter into those, right? So I can right click here and apply as filter selected and show me everything between A and B here. And that's going to give me one conversation. In this case, it's a conversation between these two IP addresses. One of them looks to be a DNS server, so we see a lot of our DNS coloring rules that are going into effect here, which is pretty cool. Looks kind of Christmas tree-like with all the red and green. But this is just one of our specific conversations. We can follow that conversation here. We can follow that UDP stream here, see the content of that, and so on. Of course, we'll do more of that a little bit later. Now, in this case, we've created a filter here that says UDP stream equals 1. So we can filter on these things, which is pretty neat too. One of the things I want to look at here is actually colorizing these conversations, right? So giving each specific conversation its own color so we can track it. Not all the conversations are going to be linear. So it's not going to be like the first 20 packets are one conversation, the next 20 packets are another conversation, and so on. We'll get to a point where these conversations are going on at the same time, so systems can have multiple conversations at once, and they're kind of interwoven together. So being able to quickly visualize which conversations are different from the other one based upon color is pretty neat. So what I can do here, right just from the packet list window, is I can click on one of these conversations. So in this case, we see, starting at packet 3, we see a SYN followed by a SYNAC followed by an ACK. And these three packets represent the setup of a TCP connection. So we have a new conversation starting here. So what I can do is actually right-click on the first packet in this conversation, go to Colorize Conversation, tell it I want to colorize it based upon, in this case, we'll base upon the TCP level conversation. So we're talking IP addresses and ports. And we'll go ahead and colorize it here just with color 1. And you see immediately, this is a pretty short conversation, and we see that it looks like packets 3 through 11 here at least are involved in this conversation, and then another conversation kicks up. We see another SYN, SYNAC, ACK. So I can scroll down here, and we have a lot of other conversations going on. So let's go ahead and go to this next conversation. Right-click the packet here. We're going to colorize that conversation by TCP. We'll give it color 4 because that's quite a bit different than color 1. And there we have that conversation as well. So we see we have a red conversation, a purple conversation. We have a couple other conversations look like they're trying to be started here in the middle of this purple conversation that we've already highlighted, which is pretty neat. So we can see that's happening in the middle. That quickly tells us that these packets are not necessarily directly associated with the other conversation. Some more conversations trying to be started with SYN packets. We see some DNS traffic back to this conversation that's color-coded in purple. And you see this is also color coding this bar here. So we have a lot of purple right here, and then we have a lot more green, and then we have some more purple. So there's a lot of things intermixed. And if you look at the time column, all this is happening really fast. So it may look like we've skipped down a really long way to get back to the conversation that we colorized as purple. But really, we've only gone 0.6 seconds. So we've not gone that far. And this really illustrates the fact that we have a lot of communication happening all at once. And it's very easy for things, different conversations to get interwoven together, which is one of the reasons why colorizing packet conversations is pretty darn cool and a really useful feature. One of the things I'll do right off the bat when I open many capture files where I know I have multiple conversations going is to quickly go in and colorize all of them. So I'll do that either here or from the conversations window, which we actually just showed just a little bit ago. So I can go to statistics and conversations. In this case, I go to IPv4 conversations, or I could go to TCP conversations, and I can colorize them straight from here, right? So I can go down here and colorize bidirectional, and I can create a coloring rule in this way too, right? So I can go ahead and go in here, conversation 4. We'll just leave it with this same coloring rule. and we'll apply that and do it that way. So it's a pretty cool thing. We see that we've got that here, so I just made that white background with black text, and we see that interwoven here as well. So a lot of ways to create coloring rules, but I'll go through it immediately. Just create coloring rules for every conversation. Helps visually discern it, and especially if you're starting out and you're having trouble doing that based upon what you know on the protocols already, certainly this is a really great strategy for helping keep things organized. I would recommend it both for experts and beginners. First thing you do, figure out what conversations are going on and then colorize them by conversation. So with all that said, just a couple of quick pro tips for dealing with packet color coding. One is to remember that the order of the color coding matters. So when you go into this screen here where you're looking at the coloring rules, it may look like just a simple unordered list, but the order really does matter. I almost kind of wish there was another column here that had the number where it said 1, 2, 3, 4, 5, so it gave that sense better. But nonetheless, know that order does matter. So if you're not seeing something in the right color that you would expect, then you want to make sure it's in the right order. After that, you want to make sure your filters are correct. So we're going to go into a detailed section later on display filters, and you want to make sure you know how to use those because coloring rules are based upon those filters. Next, make sure you share these with other people in your organization. Help keep some consistency. Help keep everyone on the same page. Next, consider the fact that some people are colorblind. That's not something you might think of, but if you have a query like the one we have on the screen here where we have DNS queries are red and DNS responses are green, some people actually see red and green as the same color. So this might not show up correctly for everyone, and certainly keep color blindness in mind. I forget the exact statistic, but a lot larger percentage of the population than you would think has some degree of color blindness. So that's something you have to be a little bit aware of when you're configuring coloring rules. And last but not least, just keep in mind at any time you can turn off color coding here. So we have a nice pretty set of colored packets here, and I can actually click this little button right here to turn that off. So I can actually turn things all to white background with black text immediately using that. So if the colors get overwhelming, you just need to disable that for whatever reason. You can click this little menu bar icon right here that looks like a bunch of colored lines to disable it. I don't really ever do this. I don't run across a lot of occasions where I would need to, but for some people, the color just gets a little overwhelming and you want to kind of simplify it a little bit. So if you need to, that's where you can do that. So that's going to bring an end to our discussion of color coding. We're going to be using this feature quite a bit as we go through other scenarios in the book, so you want to make sure you're very familiar with it. And I would go ahead and challenge you right now as you're going through packet captures or maybe capturing your own packets. Start colorizing your conversations, maybe make a couple of protocol-specific coloring rules, and really dig in with this because it's a super useful feature, and I think it will drastically improve the speed and accuracy of your packet analysis.